students, isn't it very exciting to solve mysteries? Today we are going to solve one such big mystery behind the formation of millions of compounds. Compounds such as ionic compounds and covalent compounds. Today we are going to discuss the formation of ionic compounds. In our day-to-day life, we use lots of compounds, knowingly or unknowingly. Sodium chloride as table salt, magnesium hydroxide and aluminium hydroxide as antacids, potassium iodide as an ingredient of iodized salt, sodium fluoride as an ingredient of toothpaste, sodium hypochlorite as an active ingredient of bleaching powder, sodium bicarbonate, that is one common cooking ingredients in our kitchen, sodium carbonate as washing soda. Millions of compounds form only out of 118 elements. Elements consist of mainly metals and non-metals. How do metals and non-metals react? Why do they react? The answer of this question lies in the electronic configuration of atoms of elements. Let us have a look at some electronic configuration of some elements. Here are some elements. These are their corresponding atomic numbers. Atomic number is the number of protons at nucleus of the atom and number of electrons also. For example, neon, atomic number 10. One neon atom has 10 protons and 10 electrons. 10 proton plus 10 charge, 10 electrons minus 10 charge. Net charge 0. Atom is neutral. All atoms are neutral. Electrons are distributed in the K, L, M, N cells. Outermost orbit or cells called the valence shell. Now, noble gases. We already learned noble gases which have completely filled valence shell. So little activity. 8 electrons in the outermost shell of noble gases represent a highly stable electronic configuration. Other elements also want to get that stability. Is it possible for other elements to get that stability? Yes. But how? By losing or gaining electrons. By losing or gaining one or more electrons, metal and non-metals can get the stable octet structure. Now, atoms of elements have equal number of protons and electrons. So, the atom is neutral. When metals and non-metals lose or gain electrons, form cation and anion respectively. These cation and anion attract each other and are held by strong electrostatic force of attraction, thus forming ionic compounds. Now, what will happen when sodium and chlorine react? See in the table, sodium atom has 1 electron in its outermost M cell. If it loses this electron, its L cell now becomes the outermost cell. And that has stable octet. This nucleus of sodium atom has still 11 protons, but number of electrons become 10. So it becomes single positively charged sodium ion. On the other hand, chlorine atom 287. Chlorine atom has 17 protons and 17 electrons in K, L and M cells. If it gain one electron, it can complete its valence shell 288 electronic configuration. See here the structure. It is sodium atom, it is chlorine atom. The electrons of sodium and chlorine are represented by different colors so that they can be easily differentiated. When they react, one electron from sodium atom transfers to chlorine atom. As a result, sodium ion and chloride ion form. See here, sodium 2,8. It gains the stable atomic structure of neon 2,8, and chloride ion 2,8 electrons, and outermost shell also 8 electrons. See this electron, this purple color electron, it got from sodium atom. This chloride ion got the stable atomic structure of argon 288. Now these two oppositely charged ions attract each other and are held by strong electrostatic force of attraction, forming sodium chloride ionic compound. See here, sodium 281 structure loses one electron, forming sodium cation 2,8. Here, chlorine atom 287 structure gains one electron, forming chloride anion 288 structure. So this is the formation of chloride ion. Next, formation of magnesium oxide. Magnesium. Its electronic distribution: K cell 2 electrons, L cell 8 electrons, M cell 2 electrons. If it lose these 2 electrons, it will form +2 magnesium ion. On the other hand, oxygen. See, its electronic distribution: K cell 2 electrons, L cell 6 electrons. If it gains 2 electrons, then it can fulfill its octet, that is 2,8 structure, and automatically it will form oxide ion. Now see here, these 2 electrons are the valence shell electron of magnesium. 6 electrons, 1, 2, 3, 4, 5, 6 electrons are the valence shell electrons of oxygen atom. 2 electrons of magnesium transfer from magnesium to oxygen. What will be the result? As a result, magnesium +2 ion and oxide -2 ion will form. And these 2 oppositely charged ions attract each other and are held by strong electrostatic force of attraction, forming magnesium oxide ionic compound. See here, their structure 282 magnesium, it's gaining stable octet structure 2,8, nearest noble gas structure of neon. Whereas oxygen 2,6, it's converting oxide ion to its gaining 2,8 stable structure of neon. That means they are gaining stability. From this discussion, how can you explain the reactivity of elements? We can explain the reactivity of elements as a tendency to attain the completely filled valence shell. One important thing, X-ray studies have shown ionic compounds do not exist as simple single molecule. See the structure of sodium chloride. Here in the structure, purple spheres represent sodium ions and green spheres represent chloride ions. Due to uniform electric field around an ion, each ion is attracted to a large number of oppositely charged ions. One sodium ion will not attract only one chloride ion, but it will attract as many chloride ions as it can. Similarly, the chloride ion will attract several sodium ions. As a result, a regular arrangement of these ions give rise to three-dimensional lattice. Atoms are very small. Millions of atoms together barely form the thickness of single page of your copy. Wanting for stability of such small atoms give rise millions of compounds. Next class we will discuss how atoms of some elements attain stability by sharing electrons, that is formation of covalent compounds. So we conclude, atoms of elements attain stability by losing electron or by gaining electrons or by sharing electrons. And this is the mystery behind the formation of innumerable, uncountable compounds. Similarly, students, you can also gain or you can also acquire stable knowledge by gaining it from your teachers and sharing it with your classmates. More you share, more stable will be the knowledge. Thank you.